X gon' give it to you. Fuck, wait for you to get it on your own. X gon' deliver to you. Knock, knock.
What's up, nerds? Welcome back to Tea Time with your favorite software engineer. If you guys haven't already, subscribe and join my Slack channel. I have the link in the description. I post LeetCode questions every day for us to discuss and solve. So today I'm going over N-Ary tree, preorder, traversal. I'm actually going to do this recursively first and then iteratively. I don't think it's as easy as some people make it out to be, but so let's jump right into it. Given an N-Ary tree, return the preorder or traversal of its nodes values. So preorder is, in case you guys don't know, they want us to return it in order of, so when you pass the left side of the node, that's when you add it to the list. So we do 1, and then we pass the left side of 3, we'd add 3, 5, and then we'd add 6 because we're at the left side. So in order would be when you pass the bottom. So in order would be 5, 3, 6, 2, 1, 4. So here we see my trackpad is not working good. We see we have, like I said, 1, 3, Achilles, 1, 3, 5, 6, 2, 4. We're going through the left side, so whenever we patch the left side, we add it to the list. So let's solve this problem. Recursively, we're just going to have a helper function. Hi! So let's create a linked list. We know we need to return this integer, so let's call it list equals and then we just want to return our helper function that we're going to write, and we're going to pass it root and list. We're going to be returning list. So here's our helper function. We know we need to return a list again. So helper node root, oops, and then a linked list with integers. Okay, so the first thing is if the node is root is null, then we just want to return the list. That means when we're checking the children, we're not going to add anything. So if root, this is our base case, we just return list. And then so preorder, where as soon as we pass it, we want to add, well, we have root, we want to add it right away. So let's add the value to the list because we know we're adding it on the left side. So we do list.add root.val. And so what's the correct order for this recursively? So we're supposed to add 3, so we want to check the children and then add them. So let's check all of the children. We're going to do this recursively. So let's do for node and let's call it child. We're going to loop through all the children in root.children. So this is looping through these 3. So what it's going to do is after we write the recursion, so I believe it's just helper, root, and child. And we just want to return the list at the end because we need to return a list. So what this is doing is it's passing in the child first. So the children are 3, 2, 4. It's going to call the recursive function for 3 first because it's the first child, and then it's going to add it. And then it's going to call the recursive function for the child, so it's going to add 5, or it's going to recursively call 5 and then add it because we go up here. So that's how that works. Pretty simple recursively. I'm going to do it iteratively right after this if my mouse pad would work. And I messed something up. No, node cannot be converted to. Oh, okay, so this is child and then list. That was a dumb mistake. And there we go. Okay, there you have it. And now I'm going to jump into it recursively. Okay, so I have my iPad open now. This one's going to be a little bit more visual, so we're going to go over it iteratively. So obviously we're going to need a data structure to store them in and pass them into our answer array or a list as in the right order. So let's go over the problem to figure out what data structure we should use. We know that we want to add 1 right away. So if we add 1 here and then push it into here, 1. So that's the easy part. And then we're going to do the children. So if we add 3, 2, and 4, 3, 2, and 4, well, the next one is 3. So we could go from the back, if this is the back, to get the 3 out. Or if we do it in reverse order, so if we reverse them, add 4 first, 2, and then 3. And then we can pop 3 off, add it to the answer. 3, that's still in the right order. And then we add the 3's children in the right order. So we'd add 6 and then 5. So what is this? We're popping off the top, so it's last in, first out. So, or no, last in, first out. So we're gonna use a stack. I'm sure you could use a deck too if you wanted to, but in this example, I'm just gonna use a stack. So let's do this real quick. Let's create our stack. So we're gonna add, in the stack, we're gonna be adding nodes. And so I'm gonna call it stack. And then we want our list, so I'm going to use a linked list interface. And this is going to be integer, so this is what we're going to be returning. And so the base case is if root's null, then we just return list. So and then obviously we want to add root, so stack.add root, and then we're going to loop through. So we're going to loop through while the stack isn't empty, because we have to add all of these into answer. So we're just going to loop through. So while the stack is not empty, we're going to want to first, we're going to we want to put the root in first, so we're going to pop it off. So let's create a new node, stack.pop, and then we're going to add it to list. So list.add node, and then we're going to loop through all of the children in node. So I've seen other people use collections.reverse. Basically what that's doing is it's just reversing the children. You could also just go from the back using a simple for loop. So that's what I'm going to do. Node, so we're going to do node.children.size -1, and I greater than or equal to 0, I minus. Okay, so right now we've added the root, so we just have the one in here. Now we're gonna add, what we did is we added all the children into the stack, and then we're just gonna, it's gonna loop through this while loop and pop them off in the right order, add them in the right order. So stack.add node .children .get, and it's going to just be I. Okay. And then we just need to return the list. And so hopefully this works. Oh, so I always forget this. This is supposed to be, because it's an integer. There we go. And there you have it. So that's both the iterative and recursive way to do it. This problem I'm about to do it iteratively, but I also just wanted to go over it recursively. So if this video helped you guys, smash that like button, and I'll see you in the next video.
Yeah.